our way through this thing.
So wait, so calculator, I heard you was last time, this one's no calculator?
That's what we're talking about right now.
Okay.
So the first question says the graph of the function f, consisting of 3 line segments and a quarter of a circle, is shown above. Let g be the function defined by g of x equals the integral from 1 to x f of t dt. Find the average rate of change from of g from x equals -5 to x equals +5. Average rate of change means great slope. So g of 5 minus g of -5 over 5 minus -5. Writing that would have been 1 point. How are we going to calculate g of 5? Well, that's going to be the integral from 1 to 5 of f of t dt, right? Do you have an equation for f? No. What do you have for f? A graph. How are we going to calculate the integral from 1 to 5 of f? We're going to do the area under the curve. So if I do that, it looks like this divides into a triangle and a rectangle, right? So the triangle is 1/2 base times height. So the base is 2 and the height is, I didn't number those, 2, 3, 4. And then the rectangle is base times height, so that's 2 times 4. So that's going to be 12. That would have been 1 point. G of -5 should be the integral from 1 to -5 f of t dt. What do you see that's weird about that? Yeah, the bounds are opposite what we'd expect, so we'll negate the integral so I can flip the bounds. So now if we go up here, so let's see, -1, 2, 3, 4, 5. So we have this triangle, this half circle, and that little triangle. I should say quarter circle. Everybody's good with that? Okay. And then 1, 2, 3, 4. Okay. So that's going to be -1/2. The width or the base of the triangle is 3. The height was 4. Plus 1/4 pi r squared, because it was a quarter circle. The radius is 2. Plus, and then there's one more circle that is a 1 base and a 2 heighter. That would have been worth 1 point. You would not have needed to plug the values in to simplify. You should have just been able to write it down in one messy thing, but let's simplify it anyway just for our own peace of mind. So that's going to be 6. This is minus, but all of these are below the curve, so they're all minuses too. I forgot to write the minuses in there. So then with the minus side out front, there's a bunch of minuses. That's going to be plus 2 pi. No. Pi. And then that's going to be plus 1. So you should have ended up with 5 minus pi. Is everybody okay there? Mostly a geometry question, right? Like recognizing that, oh, I just have to use geometry to do this. Yep, that would do it. The good news is if you did the g of 5 and g of negative 5 correctly, I think you would have been able to get 2 points out of that.
Yeah.
Even if you goofed the difference quotient.
Yeah, I did the math in my head though for one.
Yeah. Okay. Chanel?
So I don't really understand. So I put down the average rate of change, but like for the g of 5 and g of minus 5, like what's the difference? Like you saw the average rate of change, but then what are you doing in g of 5 and g minus 5 with the integral?
Well,
like,
it tells us that that's how you find g of 5. G of x is equals the integral from 1 to x of f of t dt.
Well, but didn't you already find the average rate of change with the 5 minus pi over 10 though? Like,
that is the answer that I got by plugging the 12 into there.
Oh.
And that part went into there.
Okay, gotcha.
So I just did it off to the side because
Oh.
maybe you probably wrote that down without realizing you're going to need to do those. I was kind of trying to do it in like an organic order, right? Like you would have done when you did the problem, right? Like we start with, yeah. Anyways, is that cool?
Yes.
Okay. All right. Part B says find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist. Instantaneous rate of change is? Derivative.
Bang.
So what is the derivative of g?
Like the. Oh, okay.
How do I do the derivative of an integral of f of t? So what am I left with? Not f of t, x.
Why f of x not?
Well, if you're doing a function, g prime of x should be a function of x, right? So you have to do like a chain rule here with whatever's, like x is the function, t is not, like this is a function of x. You're differentiating with x, right? If it was f of t, it's like getting a constant back out of it. Like that's not how that should work. So now we want g prime of 3. Well, that's just going to be f of 3. I go to my thingy-majigger. What's that? 4. Right? That was just 1 point if you got the answer. But it's an easy one, right? You just had to like recognize derivatives cancel, integrals, and then I'm just looking for f of 3. You could have probably just written the number 4 down with doing nothing, and they probably would have given you the point. Part C says, on what open intervals, if any, is the graph of g concave up? What is concave up? How do I find that? Yeah, so g double prime should be positive. So we know g of x is equal to this integral, right? We know g prime of x is equal to f of x. So g double prime of x should be f prime of x. So if we want g double prime of x greater than 0, that's the same thing as looking at f prime greater than 0. We don't know anything about f prime, right? All we have is the graph of f. So what am I looking at in f to show me that f prime is greater than 0? what feature is f going to have when f prime is greater than 0?
When f prime is greater than 0 on the slope of
Great. So I'm going to write f is increasing. So that's what we're going to look for. So if I go back up to my picture, let's see, where are we increasing at? Here and here. So -5 to -2, and then 0 to 3. I think this explanation was probably 1 point, and the answer was 1 point. So it says 2 points for intervals with justification, somehow indicating that, I don't know if you would have had to go all the way to f is increasing, but you would have had to definitely show that f single prime greater than 0 is equivalent to g double prime greater than 0. You'd have to write that at least, I think, for your justification. Would be my suspicion anyways. Yeah.
Because, like I said, g double prime equals f prime t, and the slope of f is positive, which means the double derivative g at this point is positive.
That's probably good, yep. I think you included all the big ideas there that you would have needed to justify how you got your points. I would have thought that would be enough.
Yeah, I meant to write that, but instead of writing g double prime at the points, I wrote f.
Oh, see, yeah, you do that and I can't give you anything, yeah. So you have to be,
You just cross out g.
yeah. Yeah. So again, on these, hopefully you're seeing that, like, I'm giving away some easy points just by, like, not being careful with my notation. Like, making sure, really make sure you're writing down what you mean. All right. The last part here, it says, for all x values from -5 to 5 at which g, or find all x values which g has a critical point. How do I find a critical point?
Equal to 0, and then test the ends too.
Oh, close. So g prime has to equal to 0, or undefined. So you can have a critical point where the derivative is 0, or when it's undefined. Now, I don't need to test the endpoints here, Nolan, because it's an open interval. So I don't need the endpoints there. It wouldn't be wrong if you did, but again, as soon as you hear local, you shouldn't need the endpoints. If it says absolute, then we need endpoints. Good catch, though. That is potentially something we have to do, and we do have to be careful about whether the interval is open or closed, and or whether they say absolute or local, right? So it makes a big difference. Okay, so I know that g prime of x is equal to f of x. So if I want g prime equal to 0, that's the same thing as just looking at f equal to 0. Now if I go back and I look at f is defined everywhere, right? So I don't have to worry about that. I just have to worry about where f is 0 at -2 and 1. So 1 point would be to have written that. 1 point would have been finding them. And the last point is going to be our justification. So remind me, for a local minimum, we go from decreasing to increasing, right?
Yeah.
So the derivative goes from negative to positive, changes signs. For a maximum, we go from increasing to decreasing. So the derivative changes sign from positive to negative. Let's go back and look at what's going on here at f. So here at -2, it's going from negative to negative. That's nothing. Here at 1, it's going from negative to positive. That's a local minimum. So that's going to be my explanation. So I would say x equals -2 is neither, because g prime does not change signs at x equals -2. And I would say x equals 1 is a local minimum, because g prime changes from negative to positive at x equals 1. And that would be your last point there, is those explanations. And again, look at how nicely worded that is, where you just say the sign changed at this point from this to this, or didn't change from this to this. And that's clean, right? You don't have to worry about mucking around with, like, you could probably draw a sign diagram here and that would be okay. Would probably give you the same points as writing the explanation words. This feels a lot safer to me than writing a sign diagram, because now you have to count on the reader knowing that that's what the sign diagram is supposed to be doing. And I've not been in the room with the graders and like how much extra notes they have of like, okay, this counts as an explanation. This is an equivalent to this. This is equivalent to that. So if it asks for a justification, I would try to stick with words, or at least like equations, like the sign diagram, the picture. I wish I could tell you for sure if that's good enough or not. But I don't know for sure. Number 4 says the function f satisfies f of 0 equals 20. The first derivative of f satisfies the inequality of 0 is less than or equal to f prime of x less than or equal to 7 for all x on the closed interval 0 to 6. Selected values of f prime are shown in the table above. The function has a continuous second derivative for all real numbers. Use a midpoint Riemann sum with 3 subintervals of equal length, indicated by the data table, to approximate the value of f of 6. So if this is going from 0 to 6, and we want 3 subintervals, how long those subintervals have to be? 2 units long, right?
Yeah.
So that's going to be 1 subinterval. That'll be the second subinterval. And that would be the third subinterval. Was okay? So my Riemann sum, so Rm is my midpoint Riemann rule, is going to be the width of the subinterval, always going to be 2 in this case, and then the height of the middle point. So like in this case, f prime of 1 or 3.5. For the second one, it would be f prime of 3 or 0.8. And then it would be f prime of 5 or 5.8. And when you do that, I think it's like 20.2 or something. And again, you wouldn't have to necessarily write that, simplify that out. I think if you had gotten that without simplifying it down to 20.2, that would be 1 point. But that is not the answer. So you know that 20.2 is approximately the integral from 0 to 6 of f prime of x dx. That's what you found, right? But what do we want? We want f of 6. What else is the integral from 0 to 6 of f prime of x dx equal to? It's equal to f of 6 minus f of 0, right? That's the fundamental theorem of calculus part 2. Writing that equation would have been worth 1 point. We know that f of 0 is 20, so adding that over gets us our approximate value for f of 6. That's the final point. Whenever you have an integral and it's talking about like some specific value, you're probably using that fundamental theorem of calculus part 2. We've seen that a couple of times now between the multiple choices and the free responses. That's come up a bunch of times. It's an important theory. They're going to want to make sure you recognize it. Be prepared. Okay. Part 2 says determine whether the actual value of f of 6 could be 70. Explain your reason. So we know that the derivative of f of x is between 0 and 7, right? So we know the integral from 0 to 6 of f prime of x dx has to be less than or equal to 7 dx. Because that's the biggest possible value that f prime could be. What's the antiderivative of 7?
0.
7x. And if I evaluate from 0 to 6, I get 42. Right? And I know that this could also be f of 6 minus f of 0. Right? And if I add the 20 over again, I get that f of 6 has to be less than or equal to 62. So no, f of 6 is less than or equal to 62, and I'm probably done. What does it say here? So it wanted 1 point for recognizing, well, I should probably say that, yeah, let's just say here. For that line of reasoning, that you can, because f prime is between 0 and 7, the integral is less than or equal to 42. And then 1 point for finishing her out and showing that f of 6 has to be less than or equal to 62. Is that okay there? This was the trickiest piece, was like getting that. If you made that realization, you probably got enough to get minimum of 1 point, probably more, out of there, because it wasn't too hard from there. It was really the same problem as before, right? Just instead of using the midpoint Riemann sum to do the integral, you just integrated 7. But you had to recognize that that's what you had to do there. C is the easiest problem or easiest part of all the free responses. What is the antiderivative of f double prime? F prime. So this should be f prime of 4 minus f prime of 2. Stating that was 1 point. How do you calculate f prime of 4? Go to the table and read it off the table. And then f prime of 2, you go to the table, read it off the table.
You got 1.3. Oh, yeah.
And your second point would be for your answer. And again, I think if you left it as 1.7 minus 2 and didn't do anything with it, I think you probably still would have gotten that second point. Right? They shouldn't require that you do simplification. Like once you've like you've looked up everything and you have numbers down in all the spots, that should be done. You don't actually need to combine like terms and simplify or any of that nonsense. Everybody okay on this one? The last part here, it's a limit question. How do we want to start? Well, we have f of x in here. We don't have a function for f of x. So I don't know how you'd graph that. I would start with just a direct substitution. So if I plug 0 in for x, f of 0 is 20. So we end up with 0 over 0. What does that mean for us on a limit? L'Hopital time, yeah. So to do L'Hopital, remember, we don't take the derivative of the entire integral. We just do the derivative of the top and the derivative of the bottom. What's the derivative of f of x? F prime of x, that's right. You don't need a constant because there's nothing, it's not f prime or f of 2x or something. There's no chain rule. I mean, you could have a 1 if you want, but like, who needs that? What's the derivative of 20e to the x? Yeah, that's right. And then what's the derivative of 0.5 f of x? Yep, 0.5 f prime of x. And the derivative of 10 is 0. So now if we direct substitute this, we have f prime of 0 minus 20e to the 0 over 0.5 times f prime of 0. I go to my table, what is f prime of 0? It's 4, which is great because now I don't have a 0 denominator. So you got 1 point for doing the L'Hopital and 1 point for the answer. And I suspect even if you left it there, you would have been fine. Once you had the f of 0 plugged in for 4, I think they would have been okay. So if you're catching yourself making lots of silly arithmetic mistakes, don't simplify. Because here's the thing, folks. If you have the right thing written down and then you simplify it incorrectly, I don't think they'll give you the point. If you have the right stuff plugged in and you don't simplify it, I think they're going to still give you the point. Pretty sure. This was something we talked about a lot when I did the training, as we spent a lot of time talking about how things are scored. I want to make sure that I'm coaching you appropriately as to like, what's the best way to avoid throwing away points, by doing something silly. Where you said, oh, e to the 0 is 0. It's like, no, it's not. All right. Let's look at 5. So it says, let R be the region in the first quadrant enclosed by the graph of f of x equals yada, 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 and g of x equals yada, yada, yada. And the vertical line, x equals pi over 2, as shown in the figure above. Write, but do not evaluate the expression that gives you the area of R. Okay. First question I'm going to ask you, looking at the graph, how can you tell which curve is F and which is G? Braden? Okay. So if you do cosine of pi over 2, that is 0. So that tells us that this guy is F and that guy is G. Have to be able to tell the difference between those. They're never going to give you something that's so close that you can't tell. The way I did is I just looked at it and went, exponentials look like this. That's got to be the first one, right? good enough. But like whatever. Somehow you have to tell. Shouldn't be that hard to tell, but you do have to think about it for a minute and get that right. If you get it wrong, you're in big trouble, mister. Okay. So how do I calculate then that area for R? I'll just write it as A. It's going to be the integral from what to what? Yep. And then what is the integrand? Yep. And here's the way I would write it. I'm just going to write it that way because it's less chance of me goofing it. Like if I write something wrong, getting the limits correct was 1 point. Getting the integrand correct was 1 point. Why do you suppose they ask you to not evaluate this? That is a son of a gun because of that thing is not going to be fun to integrate. In fact, I have no idea how to even go about trying that because it's not a parts that I can see. It's not a U sub. I don't know what to do with that. Yeah. So again, make sure if it says don't evaluate, you don't waste a bunch of time trying to do it because I don't know what you would do there other than waste a bunch of time. Part B says find the solid generated when R is revolved around the x-axis. Let's go back to our picture. So R is being revolved around the x-axis. So we're going to have some kind of solid, right? We're going to use discs or washers. Won't be shells because it's the AB exam. There are no shells. Disc or washer. The one with the hole in it is the washer. You can tell because there's like a gap between the solid and the x-axis. Okay? Great. So what's the formula for washer? Good. So our volume then is the integral, well, we'll do pi times the integral from what to what? Yes. And then the inside should be? Yep. I'm just going to write it like that for now. I think that's right. Yeah, G of minus F. Okay. And this one, they want you to do the calculus down for it. So e to the x squared is e to the 2x. The square root of cosine squared is cosine x. What's the antiderivative of e to the 2x? What do we need to do that? It's a u sub. So you could write it out, but this should be a u sub you conceivably could do in your head. Now, I wouldn't do it on my head on the AP exam because I wouldn't want to screw it up. But like, we're all here. We're big boys and girls. We should be able to do this u sub in our head. Yeah, I'm just going to write it that way. E to the 2x over 2, or 1/2 e to the 2x. Correct. And the antiderivative of cosine x is? It's just sine x. Because remember, the derivative of sine is cosine. So we're just undoing it. And we're going from 0 to pi over 2. So if I plug in the pi over 2, what is sine of pi over 2? Mm-hmm. And sine of 0 is? Mm-hmm. That should be enough. You shouldn't have to go further than that. If you wanted to, you'd have e to the pi over 2 minus 3 over 2. Oops, with the pi still out front. All right, let's see. Where were the points here? You had 1 point if you got that set up correctly. You got 1 point for doing each antiderivative correctly. And then you got 1 point for the answer. And again, I think that second to last line that we wrote would be sufficient. I don't think they would need you to simplify it past there. Once it's all numbers, you should be able to stop. Chanel?
May I go to the bathroom, please?
Certainly. Does that feel okay here, folks? All right. Part C says the region R is the base of a solid whose cross sections perpendicular to the x-axis are semicircles with diameters in the xy plane. Write, but do not evaluate an integral expression that gives the volume of this solid. All right, so I draw my cross-section perpendicular to the x-axis. Those are my diameters. The area formula for a semicircle is 1/2 pi r squared. Now my diameter I'm going to get by taking like this y and subtract that y from it, correct? So that y2 is g of x and y1 is f of x. So what's the radius then if the diameter is g of x minus f of x? It's divided by 2, right? So my volume should be the integral from what to what? If our cross sections are perpendicular to the x, we're going to be moving along there. That was 1 point for getting the bounds. And then the formula, I'm going to put the pi over 2 out front, I guess. And then we have g of x minus f of x over 2 quantity squared dx. Having that pi over 2 out front was 1 point, and having that integrand piece was the third point. Oh. Oh, sure. Yeah. So again, like, good to get all these silly mistakes out of our system where it's like all of these, you know, like even though it's not on the same page, I got to get used to flipping back and like pulling the form. But even if you did just like F and G's, like that's enough. You didn't have to plug in the formulas, right? You could. It's not wrong to do that. I would not. I just less writing. All right. Our last one says at the instant that the first circle has a radius of 9 centimeters. Oh, I'm sorry. For 0 to 6 seconds, a screensaver on a computer shows 2 circles that start as dots and expand outward. At the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of 3 over 2 centimeters per second. Find the rate at which the area of the circle is changing at that instant. Indicate a unit of measure. What kind of problem is this? This is a related rates problem. Okay? When I read this first sentence, at the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of 3/2 centimeters per second. What is that sentence telling us? dr dt, yep, I'm going to write it that way. When r is equal to 9 equals 3/2. Everybody's okay with reading that? What are we looking for? dA dt when r is equal to 9, same instant, is equal to what? Okay? So we need an equation that relates radius and area for a circle. What is that equation? Area equals pi r squared. Now, if I take the derivative with respect to t of both sides, what does a become? dA dt. What does pi r squared become? Excellent. This was 1 point. So if we plug things in, we have 2 pi times 9 times 3/2. That was 1 point. And the unit here should be what? It's dr dt, or dA dt per second. And that would have been your third point. And again, you could have changed, you could call this 27 pi if you want. But they shouldn't mark you down for not simplifying it. At minimum, this should be doable, regardless of even if you couldn't do any rest of it. Because it's area, it's the derivative of area with respect to time, right? It should just be some unit squared per time, and all the units in there that we needed were given to us, right? Well, again, like when it says indicate units of measure, that's going to be a point. That'll always be a point. If they ask for the unit of measure, that's a point. If you can just write down the unit of measure will be this, and even if you can't do anything else, that's a point. Pick those up because they're just laying around for you, right? Like even if you couldn't do anything else in that problem, and I recognize that the related rates are hard. This was a pretty easy one because the formula was easy to come up with. You didn't have to combine two equations together to do anything. This was and I would suspect on a no calculator piece, this would be the level of related rate I would expect to encounter, where you didn't have to go crazy and do Pythagorean theorems and have radicals and stuff rolling around in there. All right, anyways, it says the radius of the first circle is modeled by W of t equals yada, yada, yada from 0 to 6, where W of t is measured in centimeters and t is measured in seconds. At what time t is the radius of the circle increasing at a rate of 3 centimeters per second? What is this equation asking you for? Okay. It's asking you to solve for W of t equals, or W prime of t equals 3. How do I know it's W prime? It asks for a rate. This was 1 point. Writing that down. Yes, sir. Again, if you read and understand, like, what is it that I need to write the equation for, lots of points to pick up, even if you can do none of the math. If you can just read and understand what it's asking for, lots of points laying around. Pick them up. Okay, let's calculate W prime then. So what's the derivative of 12? 0. What's the derivative of negative 12 e to the negative 0.5t?
6 e to the negative 0.5t.
Great. So Nolan did a chain rule in there. So he took the derivative of the top. That's where the negative 0.5 came from. You don't necessarily need to have done that. Is everybody okay to there? So we divide both sides by 6. Take the natural log of both sides. And then multiply both sides by negative 2. So you would have gotten 1 point for doing the derivative, and then 1 point for solving for t. C says a model for the radius of the second circle is given by the function f from 0 to 6, where f of t is measured in centimeters and t is measured in seconds. The rate of change of the second circle is given by f prime of t equals yada, yada, yada. Based on this model, by how many centimeters does the radius of the second circle, increase from t equals 0 to t equals 3. This, I think, was the most correctly answered question on this FRQ. Most of us were able to just recognize this as like an accumulation problem, that all we needed to do this, recognizing that that's the integral that we needed was 1 point. If I do the antiderivative, correctly, that was 1 point. And then plugging those values in, was the third point, and they shouldn't have penalized you, but this comes out to be 3. So you'd say the radius is, I would say it does, increases by 3 centimeters from t equals 0 to 3. I think that was the last one. That's it, dudes.
So next class is the MCQs.
We've done all the MCQ go-throughs. We've done all the FRQ go-throughs. Next class is the super fun review game, where you have the opportunity to earn for yourself a 50 out of 50 test grade, or a 40 out of 40 test grade, or a 30 out of